Hello. Oh. Hey, you guys hear me? Yeah. Hello? Yeah. Okay. Hello, guys.
Hi.
Good afternoon.
Good afternoon.
Good afternoon.
Good afternoon.
It is we're very pleased today. I'll represent Taipei Ethereum Meetup. It's Yao. I'm co-organizer of the meetup, and we're very glad that we have Vitalik here with us today to give a special keynote presentation. And we'll start on 2 o'clock sharp. So if anyone needs to go to the bathroom, it is outside the conference room. Go left, and there's a door. Just go straight to, and you can get the bathroom. And before we start, I have several things to housekeeping to tell you. Is Sonny here? Microsoft is the primary sponsor of this event, so we're glad to have Sonny from Microsoft. She'll giving us a short presentation, about 5 minutes. We'll start at 1:55, and we'll invited Vitalik on stage at 12 o'clock, 2 o'clock sharp. All right. So if you guys need to go to the bathroom, grab some water, you can do it now. We'll start at 5:50, at 1:50. All right.我以为是。我上软过了，我上软过了。接下来就是大概讲起来。 live stream here today. So please retweet or share our live stream links to your Facebook wall. And set the privacy to public. Do not set it to me only, because no one can see it. So because we actually have about 60 seats today, and we only have about half full, so if you wish to come over to the front, you can just move closer to the stage, so we can leave the movement to the back of the room, so it wouldn't interfere with our live stream. So if you can do so right now, it will be really appreciated. And we're going to start in 1 minute. If you guys need to grab some water or go to the bathroom, it's a time. If not, I'm here to introduce you Ron from Microsoft. He'll give us a short presentation about what Microsoft can offer to our Ethereum community in Taipei. Welcome, Ron.
Hello. Do I really need to speak in English?
No.
Okay. First of all, I want to thank Vitalik. You gave us a very good speech last Friday. We have a lot of positive feedback from our customers. So, yeah, just back to me. I'm Ron Lin. I'm the product marketing manager in Microsoft. I'm responsible for the open source. Yeah, it's very strange. It's open source in Microsoft. That's me. I'm the guy who is responsible for the open source solution, whatever partner ecosystem. Yeah, that's all the English I can talk right now. I have to speak Chinese now.
No problem.
那其实我们这边因为我这边是 marketing 的角色。我主要是负责跟我们的一些合作伙伴，还有一些怎么去 promote 我们的市场。那我们的市场大概主要 target 在目前都是云的市场。那我们有很好的 partner， 像 Alex， 那他帮我们做了很多的 solution。但是我现在有一个比较迫切的需要，也就是说 blockchain 的应用在台湾这一年，其实我们谈的蛮多。那我们从我来角度，我们在 landing 的几个应用的案例。那我们否系未来的6个月到10个月，我们会有非常多的案子。但是我们现在是非常缺少这种 blockchain 的技术人员。那你说微软有没有这样的技术人员？那我们在 Raymond 我们有一个 dedicated blockchain 的 engineering 团队。但是呢，其实我们希望能够培养在台湾有这样的一个技术能力，这也是为什么我跟 Sunny 是负责我们 startup 的也算是产品经理。但是我这边呢是更迫切希望说有台湾的技术团队可以帮我们企业导入 blockchain 的一些应用。那如果说我不废话不多说，但如果说各位如果有兴趣的话，待会我们可以互相交换一下名片。那因为我们是非常急需要类似这样的一个技术人才，那这个就是需要各位帮忙。OK。
Cool. Oh, all right. So Vitalik will give a short, well, not exactly short, about he'll give a presentation about 2 hours and Q&A sections included. So if you have questions, write it down or put it on your paper, or we have a live stream section for people on the live stream. They can ask questions too. We have dedicated team to review the questions. We will pick the questions. We'll pick a few questions from the live stream, and we'll also take questions in this in-person presentation. So if you're ready, we agreed that we started at 2 o'clock, so let's roll. Okay. Vitalik.
Okay, great. Well, thank you everyone for coming. So what I'm going to do today is basically give a general introduction to Ethereum smart contract programming, and we'll do a bit of live coding and hopefully make some very simple Ethereum applications and write the code, publish them, run them on the blockchain, basically go through the entire process of what writing a very simple dApp looks like. So, So the programming language that's used in Ethereum to write contracts is called Solidity. It's like fairly similar to things like C++, JavaScript, and so forth, at least in terms of style. But there are a few things in it that are kind of specific to Ethereum as well. But we'll basically go through them as they come. So we'll start off by just to show the what Ethereum can do. We'll start off with a very simple example. And so the very simple example here is basically a splitter contract. So what we're going to do here is we're going to write a piece of code. And what that piece of code does is you send the transaction. And when you send the transaction, we'll write the code so that it splits the ether, splits whatever ether you send in half, gives half to one address, and gives half to another address. So not very interesting, but at least we'll get to see sort of how all the different moving parts of the blockchain work. So we'll start off, we'll just get the list of accounts that we'll use, remove these two.
You don't have to be 2.0?
No, just 2, actually. So, I'm not sure if Solidity actually supports floating points. Well, no, Solidity definitely doesn't support floating points. I'm not sure if it supports any kind of decimals. So, there we go. So this is actually a compiler that's like inside of, it's a web compiler, so it's a compiler that's written in JavaScript inside of this website. So if anyone wants to follow along or do this themselves, they can just go to ethereum.github.io/browser-solidity. So now you have this piece of code in Solidity, and Solidity as a programming language gets compiled into bytecode. And bytecode is this much more compact representation, and this is what actually ends up going onto the blockchain. So what we're going to do here is, let's see, parity is running, hold on.
So contract name can be the same as function name?
Yes, so when the function name is the same as the contract name, that basically means it's a function that gets called once when you create the contract. So over here, what we're going to do is we're just, since we're using parity, we're just going to use the JavaScript console to have to restart it by using RPC or delete. That should work. Here we go. So what we're going to do here is we're going to, we'll just check, hold on. Let's check what the accounts are. We'll send with the first one. Actually, I think it might be easier to do it from here first. see what's going on. Hold on. Hold on, I think it's working now. And let me go back to sharing the screen. There we go. So what I just did is basically I just unlocked an account so that we have an account that we can use to send transactions from. So what we're going to do now here is we are just going to send a transaction from account 0, and the data is going to be basically exactly what we have over here. And the value is going to be, let's say, 0.02 Ether. So we set, so over here, let me just see if I can. Basically, what we did here is we just used JavaScript directly to send a transaction, and we're going to see if this, we're going to watch this transaction appear on the blockchain. So we'll go over here, Ethereum / transaction / this, and we'll wait for a bit. So, in general, I mean, one of the properties of blockchains is that they're not extremely fast, and it does take a few seconds for a transaction to actually pass through the network and get included. So, we do have to wait. If we're impatient, the other approach that we can try to do is if you take this, then you have the transaction data. Oh, there we go. It's already it got through the network now. So now you can see it says pending. So basically, at least Etherscan knows about the transaction, which means the transaction is broadcasted. But we still have to wait for it to actually get included into a block. So this whole process takes some amount of time. Actually, let me just check to see on NetStats how. So I guess 1 minute. Network is doing fine. And that was a new block. Also, no transactions in it. Next time, we'll probably consider raising the gas price a bit. So basically, we just have to wait a bit until a block comes around, which includes our transaction. And there we go. We saw one that included some, and included. So over here, what you can see is you see the transaction. And if you click on it, and if you actually look over here, you see that this transaction triggered 2 transfers. So you see 0.01 Ether was sent to here, and 0.01 Ether was sent to here. So basically, the transaction did exactly what the code said that it would do. Now, technically, this is a piece of contract code, but this doesn't really create a contract, right? Because the only function that I have here is the is the initializer, and the initializer only runs once. The initializer only runs when the contract gets created. So aside from this, like the contract by itself actually doesn't do anything. So far all we've done is we've basically made programmable value transfers. If we want to have an actual contract where you have an actual program that's on the chain, and that program is can hold funds, you can interact with it, the program can have a sort of fairly complex internal state, then we can move on to the next example. So the next example I usually use is the escrow contract. So over here what I do is, in an escrow contract there's generally three parties. So there's a seller, buyer, and arbiter. So the sort of story here is that, let's say, for example, I'm trying to sell a phone. Let's say I want to sell this phone to you for 0.04 Ether. So now one problem, and we're doing this online over some kind of e-commerce platform. So one problem is, if I just basically, do I send the phone first or do you send me the money first? If I send the phone first, you might receive the phone and you might decide, well, I'm going to be evil today and I'm not going to pay the 0.04 Ether. If you send me the money first, I might think, oh, I'm not going to send the phone, I'm going to keep the Ether. So instead, we solve this trust problem with a smart contract. So the logic of the smart contract, well, it basically says, first, I send the money into this contract, then first you send the 0.04 Ether into the contract, then I mail you the phone, then if everything is okay and you receive the phone, then you confirm. And when you confirm, then the money goes to myself. Now, if I don't confirm. If you don't confirm, right, so one possibility is if, let's say, the buyer doesn't confirm and the seller doesn't refund. In that case, basically, we leave it to some third party to decide which one of the two to sell. So this still has some trust in it, but it has much less trust than just giving the money to a third party, because the only choice that the arbitrator has is they can give it to the buyer or give it to the seller. They can't take it for themselves. So in this contract, we're going to save some state variables. So we are going to say, actually, we technically don't even need the buyer here, because what we can do is we can say, well, the buyer is the person that sends the money. Now what we can do is we can have a function that says finalize. And the function for finalize basically is that if the buyer wants to finalize, then what we're going to do is we're going to say seller.send this dot balance. Then we're going to have a function that's called refund. And the refund function, basically what it does is if the seller for some reason can't send the product, then the seller can voluntarily refund and say, well, I can't do it, but you can have your money back. So, and there we go. Now, does anyone see any flaws in the logic of this contract so far? So right now, as it stands, this contract code is actually not very secure. It doesn't quite do what I said. Yeah. So why not? What's the problem?
Everyone can.
Correct. And anyone can finalize. So we're going to let the buyer finalize for this, or we are going to let the arbiter do it. And over here for refunds, we're going to obviously let the seller refund, or we're going to let the arbiter refund. So now we have something more interesting. because over here you might notice that the initializer has arguments in it, which means that we can't just copy the bytecode. We do have to deploy it in a slightly more complex way. So let's do that. One thing here is that this 4.7 million gas doesn't work. We probably want to reduce it to 1 million. Let's see, you thought account 0 is fine. Now for seller, we're going to sell the, let's say the seller is this address. And let's say the arbiter is the, well, this address, which is the Ethereum Foundation.
So usually who picked out the trader?
Well, generally in this kind of application, the buyer and the seller would both have to agree on one beforehand. So you do this, XOR. And what I'm probably also going to do is I am going to say add since we're selling the phone for 0.04 Ether, we'll add that in. So this is basically a piece of JavaScript. So what we're going to do is we are basically going to just paste this all in the browser and just have all of it get run. And ooh, it's this invalid params. So there's some kind of bug here. Actually, I believe we've probably seen this before. There we go. So this is one bug to watch out for. When you see hex data, always make sure there's 0x in the front. Now, by the way, the reason why this isn't working perfectly is because like most of these instructions, they were designed with the idea in mind that people would be using the Go client. But right now, like because the blockchain is like a bit sort of temporarily bloated from the recent attacks, there's a lot of people are switching over to parity because parity like basically is more space efficient. And like even though parity works quite well, it's at the same time like there's still a few kind of kinks in how it interfaces with a few other things. So something to watch out for. I mean, in the long term, you can probably go back to GEF, especially once the line client gets done. It's just that on my computer, I only have about 10 gigabytes of space left, and GEF would take about 11 gigabytes. So I am very sad. So, okay. Or ooh, that's just weird. Okay, let's try this again. And hot error can't type address of undefined, but error, the contract code could not be stored. Please check your gas amount. Hold on. Should not be taking that much gas. Okay, so one other thing that we could do here is we could try to increase the gas amount to, let's say, 1.7 million. Just push it up slightly. And there we go. I think this time something has happened. So you can see over here you have a transaction hash. So what we are going to do is we are going to go over here and we are going to wait for this transaction to confirm. Now, by the way, in the long term, a lot of this, for average users, like you're not going to, users are not going to need to actually poke into the JavaScript and do this to send transactions. This is basically one of the kind of more bare bones and low-level ways to do everything. In general, when you as an application developer, in general, application developers are going to write code and users are going to go access Ethereum applications through fairly pretty and accessible interfaces, right? So, the way normal people are going to interact with decentralized applications is things like this, basically. So, just to keep in mind, so as not to scare people. But for now, we can just wait for this to get confirmed. It's possibly going to take some time. Let's see, what is the gas price? 21.25. Yeah, the challenge here is that this transaction is fairly big, and creating contracts is often something that does take a bit more time. I do wonder why Parity rejected that 1 million gas. It's weird. Nope, nothing yet. So what we could also do is we could increase the gas price to 100 million, reduce the gas consumption to 1.5, and we could temporarily set the nonce to 590. So if this transaction doesn't get included, we could always try basically overriding it. Yes, this is all the main chain. So actually, let's try doing just that. Unable to locate transaction entry, okay. So transaction nonce is too low. Interesting. Oh, and there we go. The old one actually got mined. So we actually got in. Okay, so what happened here, so, right, gas used 300,000, cumulative gas used, basically the transaction got included, and we actually see that a contract was created. Over here, 0x985, and on this block explorer, we can go look and we can see it. Oh, cool. So here's something interesting. You might notice that Etherscan doesn't just show you the bytecode, it actually shows the source code of this contract. Now, why is it doing, well, how does it do this? So the answer basically is that I actually did this workshop about 5 times before, and the last 5 times I did this, I used this exact same example. And so I wrote literally exactly the same piece of code, and Etherscan just automatically matched this contract against that piece of code. So basically, the block Etherscan knows that contracts with the exact same bytecode exist, and someone already uploaded source code for them. And Etherscan that time before checked basically that the source code that I uploaded matched the bytecode. And basically, it compiled the source code itself, checked that the bytecode matches up with what's on the chain, And then it showed the source code, and this contract has the exact same code, so it shows what the source code is.
So what's the new one?
So,
What is the new contract? Will it show the source as well?
yeah, so basically, like, if you make a new contract and that new contract has the exact same code as some other contract, then it'll like match and it'll show the source for you. If you make a new contract that has like different code, then Etherscan has a tool where you can upload the source code, and it'll compile it and check it, and if it matches, it'll upload the source code. So this is actually a fairly convenient way of where if you are considering participating in some smart contract on Ethereum and you want to check whether or not it actually does what the person says it does, like checking the code on Etherscan is one of several ways of doing it. So you can see here basically you have all the functions, you basically have all the logic. So transactions are only one. Read contract. Let's see, no contract API, available contract API methods, fine. Contract creation bytecode.
So is code obfuscation works on smart contract?
What kind of application? Obfuscation?
Obfuscation, yeah.
I mean, so cryptographically secure code obfuscation is something that's only been researched for about the last 5 years, and it's very hard, very complex, and it's extremely inefficient. So basically, like it takes like 100 million years to multiply like 2 4-digit numbers. So, like it's not really realistic right now. If you do want to preserve the privacy of smart contracts, there are things that are more realistic, things that are being developed to do that, like involving like ZK snarks are probably the more realistic technology that you'd use. But for that to actually get integrated into Ethereum, you might want to wait another maybe half a year or so. I mean, the other thing you could do is you could try to like make your own not very secure obfuscator, and like if the value of your application is under maybe $100,000 or so, it should be fine. But if you do it reasonably well, but I mean, it's not something that mathematicians recommend for applications that wants to be extremely robust.
So now the contract has been accepted.
Yes.
So you send it to the person.
Right, so now what we want to do is like, the contract exists, right? And the contract has 0.04 Ether inside of it. So, okay, so now what we're going to do is we are basically going to say, okay, I as the buyer received the phone, and the buyer is going to finalize. So, let's see, there we go. So, you can see in the JavaScript code here that we actually created a JavaScript object that was called escrow. And there we go. Ooh, that's the problem. It turns out that we actually overwrote it, but we can just recreate it. Basically, what we can do is we can create a JavaScript object, web3.eth.contract. Now, every contract has something called an ABI declaration, and the ABI declaration basically says how do you talk to the contract, what functions does it have, what you can do with it. So we're going to paste in the ABI declaration, and we're going to say what address it's at. So over here, it's going to be at this address. So now you have this, and what we're going to do is we're going to call finalize. And there we go. Actually, I wonder if we can increase the gas price a bit. And there we have a transaction. So let's see if raising the gas price will get it mined faster. Ooh, there's a bug here. There we go. So basically, we'll just watch and wait for a bit. This usually takes some time. Ooh, the network quality is really good lately. 0 locals in the last 50 blocks. It's actually unusual. Still no transaction entry. Generally, this just means you need to wait a bit longer. there it is. Pending 19 seconds ago, so Etherscan knows about it. So now we wait a bit more. There we go, it got mined almost instantly. So see, basically, if you really care about speed, you just like increase your transaction fee by a factor of 2 or 3, and that's also good enough. So what we see here is that this transaction triggered a transfer of 0.04 Ether to this account. So if you look at this contract, basically now it has no Ether left, and you can see this transaction, there's an internal transaction, it got triggered, and 0.04 Ether was set. So we called finalize over, right, so over here we said escort on finalize, we called finalize. And what it means to call a function is basically to send a transaction that has some specially formatted data in it. So if you want to look at this transaction, for example, then you can see here that like it has, if you look at its input data, like you have these 4 bytes here, and the 4 bytes basically are like an identifier that says call the function finalize in this contract. So this is part of what that ABI declaration specifies. So there we go. We have now successfully trustlessly sold a phone for 0.04 Ether. So so these are like some of the simpler things that you can do, but I'll also go into some more complex things. So basically, this will be a combination of 2 things. One of them is creating a crowdfunding contract, and one of them is looking into and writing an interface for that contract. So, like in general, right, as a developer, you don't want your users to be typing in JavaScript saying escrow.finalize, open curly from : web3 on without account 0. You want them to be using very pretty interfaces that look like this. So, actually, what? Oh, cool. Okay. Price of MPR is stable. That's good news. This, by the way, is basically a decentralized exchange for a cryptocurrency called MKR. So this, another sort of decentralized application basically lets you trade between 2 different assets on Ethereum without it, where the trades themselves are done with smart contracts. So you send Ether in to make an order, and then the program accepts orders, so you don't need to actually trust anyone with like any Ether or any MKR that you send into the system. It's all sort of decentralized and automated. But so back to the crowdfund contract. So what we're going to do is we are going to start off by writing up the logic here. So the story here is this. So let's say that I lost my phone, and I want to raise 0.06 Ether in order to buy a new phone. So unfortunately, I'm very poor, and I do not have 0.06 Ether myself. So instead, what I'm going to do is I'm going to create this crowdfund contract, and I'm going to ask my friends for donations. Now, the problem is that my friends might worry, well, I only have 0.01 Ether. What if I send him the money and no one else does? Then is he just going to keep? Then is he just going to keep it? And it's not even going to be enough for him to get the cell phone. So the solution is what economists call an assurance contract, where basically people send their money in, and if it reaches some goal, so in this case 0.06 Ether, then the money automatically goes to the beneficiary, and then presumably I can buy my cell phone. But if the money does not reach the goal within some time frame, then it automatically gets refunded to everyone. So people only end up actually paying, basically, if enough other people pay that the project is worth it. So what we're going to do here is we're going to specify what the parameters are. So we'll start off by specifying saying we need a beneficiary. Then we are going to say we need a goal. And we need a time limit. So basically in the initializer function, we're just going to store these variables. So now we're going to have a few functions. So the first function that we're going to have is we're going to have a function called contribute. So if someone wants to contribute to the crowdfund, then they can call this. Now, the second function we are going to want is if the crowdfund succeeds, then we want to have a function called payout. And then if the crowdfund fails, then we want a function that's called refund. So we now the other thing is if we want to actually refund people if this crowdfund fails and it doesn't reach the goal in time, then what we're going to need to do is we are going to need to keep track of a list of basically a list of participants, so that if the contract fails, we can go through the participants and we can refund them. So let's do that. So that's basically all we need. Now over here, what we are going to do is we are going to say for the payout, basically if this dot balance is greater than or equal to the goal, then this dot balance. Now over here, what we are going to do is there we go. Now, once again, this contract has bugs, and for the sake of helping people actually learn, I'll let the audience point out what they are. There's a few fairly obvious ones. There's also a few fairly subtle ones here. Yes.
Anyone can compare.
We found they only equal once.
Okay, so anyone can call payout. I mean, I'd say that's not necessarily bad, because even though anyone can call it, it still sends the beneficiary the money. There is still a problem with payout, I would argue. And with refund, I would say
Someone can call the refund before they actually reach the goal.
correct, and before the deadline. So what we're going to say here is we need if the now is after the deadline, and okay. Now, any other issues?
Or it can be called more than once.
Now, is that bad?
Well,
Because like after you call it once, it has no money left. So why would you call it again? Yeah, you could even argue that it's a good safety measure to protect against mistakes. There is still a problem in this function. I would also argue that there is a problem in these two as well, but it's a smaller one.
Should we call the payout every time someone calls the contribute?
oh,
Not necessarily, because you only want to call payout after the contract, or if the contract has raised enough money. Right? So there's not necessarily much of a point. Yes?
Contribute to the contract of the deadline.
Correct. This is definitely a flaw. Actually, yeah, let's see. Does that solve it? The answer is no, because all that I did here is I basically said, the part that I put inside of the if check is the part that just adds you to the list of funders. Like if you contribute after the deadline, it still takes the money. So we definitely can solve the problem though. What we can do is we can basically call throw. And throw just makes the entire function call fail and returns the number. Now, over here actually I'd argue that you probably want to do this.
Not before that.
Now, okay, there's still one bug here. And I'd argue it's a rather nasty one.
So initial balance is 0?
Yes. I mean, theoretically, when I create the contract, I can throw as many ether as I want into it, but I'm not going to because I'm trying to get ether. Okay, so to see what the error is here, you actually have to know a bit about how Ethereum works. So in Ethereum, every block has a gas limit. And the gas limit is basically the maximum number of computational steps that a transaction execution can take. So the problem that you see here is that if I see a crowdfund and I know the crowdfund is not going to succeed, I can stop people from getting their money back by basically contributing 500 times with 0 ether or a very tiny amount of ether. And then basically if there's going to be too much the number of loops will be too big and there's no way to do it to actually send that transaction because it will take too much gas. So what I'm going to do to solve this is I'm going to do something fairly clever. And I'll actually show two solutions. So here's the first solution. So I'm going to store refund index here. Actually, do 100,000. So here's one approach. So what this does is really simple. Basically, what it says is, well, if you can't run through the entire loop all at once, then you can just send a huge number of transactions. Basically, it'll keep on looping until it runs out of gas, until it almost runs out of gas. Then it stops. It saves the refund index. And then you can just keep on calling refund again and again until you've refunded everyone. So this is one solution. Now I'm also going to show another solution. But we'll stick with this one for the demonstration, so I am going to save the code here. So the solution is basically this. No, not quite. We're going to redesign the contract a bit. And what we're going to do is so basically what I did here is I changed around the logic so that every single user can call refund for themselves individually. So you don't need to actually have a loop inside of the virtual machine anymore. So this is basically like the name for this is a pull workflow instead of a push workflow. And this is a technique that definitely can make many kinds of contracts safer to write. And so if you write code that ends up having lots of loops, then consider doing this instead. Now, for now, I'm going to be the other approach is slightly more efficient, so I'm going to be a bit lazy and use that instead. So I'm going to go back to this model with the refund index. Like both of them are fine. And now we are going to try to deploy. There we go, Web3 declaration. So the beneficiary of this crowdfund is going to be, once again, myself. The goal is going to be 0.06 Ether. And the time limit, well, we need to do this time limit for this crowdfund fairly quickly, so we're going to do it in let's say, 500 seconds. Okay, from this is the data. Once again, don't forget the 0x. The gas, we're going to make it 1.5 million. Actually, instead of 100, we'll make it a bit cheaper. We'll say 50 billion.
How do you usually determine the gas and gas price?
So in general, the gas, so for the gas price, there is a tool that does it automatically. So in general, you don't really need to set this, but like if you want to set it to be higher, then you can, if you really care about stuff being deployed quickly. For gas, it depends on the use case. Generally, you can't calculate statically how much gas you're going to need. So in this case, for example, like one very simple rule of thumb is if you take the length of this, hold on. Now this is hex, so what we're going to do is we're going to divide it by 2 and then multiply it by 268. So this is the this is the amount that's roughly the amount that the base contract creation will cost. Then you add on top 21,000 for making the transaction. Then you add on top another 60,000 for setting these 3 variables. So it really should take about 350,000 or so. But in general, it is a good idea to put a bit more. Actually, a bit more than 300,000 because there's also a cost for creating the contract. So maybe 350,000.
Where is the 268 coming from?
The 268. So there is when you create a contract. The cost of putting every single byte is 200 gas, and in a transaction, every byte costs 68 gas, so you just add the 2. But so in general, I'm going to guess about 350,000. But over here, we're going to be a bit safe, and actually, I'm going to say, we'll start off with 1.4 million. Okay, so. Hold on. 1, 2, 3, 4, 5, 6. Sorry about that. This should work. And we are going to start off by just sort of fairly naively publishing this. See the transaction hash, so we are going to just wait.
Can a contract call another contract within,
yes.
Within a contract?
Yes, it can.
That contract might be somewhere in the ledger, right? In the blockchain, or it just has to be within itself?
No, it could be like that other contract could have any address. So there we go, we see it. So the gas prices, as you can see, is pretty high. So like I expect it to be included fairly quickly, but we can see. There's the challenge here is that on the one hand the fee is high, on the other hand the amount of gas is fairly high, and that makes it harder. Oh, and something just happened. I hope that was me. Yay, there we go, included. The joys of paying an extra 9 cents. Creating contracts is fairly expensive, so you do want to try to create contracts as little as possible. Like when you create applications, it's highly recommended that you try to create one single contract instead of creating a contract for every user. But that's just something to keep in mind. And by the way, you remember me saying that I expect 350,000 gas to create the contracts, right? So you actually can estimate these things reasonably well. And there are actually, like in some of the more advanced development environments, there are tools to estimate this too. So anyway, the contract has been created. So that's the sort of simple. Now, what we're going to do next though is we are going to move away from this mode and we are going to start thinking in terms of a DApp. So well, last time I did this, I took the liberty of sort of pre-writing the code, but in general, let me just see. There we go. Gas brace, 15. So over here, what I'm doing is basically instead of using the JavaScript console directly, I'm actually writing. Here you have the code for an HTML web page. And the idea is inside of that web page you can have the same JavaScript, you can still do the exact same sort of stuff, but from the user point of view, a user basically sees an application where that application actually looks like this. And they can press buttons and they can see numbers and like in general it looks sort of much better and more user-friendly. So start off with this. I'll probably try to. There we go. So over here, you might notice that I have that it's showing this weird number here, 5.95 times 10 to the power of 22. Now, one of the now in Ethereum, there is Ether, but there are several different sort of units of Ether. Like the unit that people normally think in, which we call Ether, and then there's the unit that all the programming is done, which is called Wei. And one Ether is 10 to the 18 Wei, so it's 1 billion billion Wei. So what this is basically saying is that in this account I have 59,000 Ether. So that's now what I'm going to do out of here is I am going to now the question is, first of all, how does it actually get this number? And we can go into the JavaScript and we can look. So over here you can see there's a button called send. Now then you have a span over here with an ID of balance. And over here you might notice I have a piece of JavaScript, where what that piece of JavaScript basically does is every time I do something, like every 500 milliseconds, it uses the JavaScript API, calls the getBalance function, and the callback basically is that it sets the value of the span to what it returns. So this is hopefully not too difficult to understand. Now, one thing that you can do is you can obviously read information, but the other thing is you want to be able to actually press buttons and you want those buttons to be able to do things. So if, for example, I click send, you might notice it says on click, when you send, there's a function called foo. And function called foo, what it does is basically it sends a transaction, and it sends it to some other weird account. And it basically just sends 0.1 Ether from one account to another account. Let me just check what this other account is. Okay. Yeah, it's just is it account 2? I'm actually going to change this, and I'll change this to, what should I change this to? There we go, I like this more. So now if I click send, you might watch. There we go. So now what I did is I click the send button, and you can see send over here calls the foo function. The foo function sends a transaction, and in the debug window you can see there's a hash there. So we can look in Etherscan. We can look up the hash, and we can wait a bit. So basically what we have here is we have a JavaScript API, and that JavaScript API automatically lets you do like all these things with the Ethereum blockchain: read the blockchain, read transactions, send transactions, and like automatically will link it to pressing buttons, but theoretically just about anything that you can do inside of JavaScript. Yes.
Why don't you have to type the password to unlock it?
So in this case, I already unlocked it. So when I launched the parity client, you might know like one of the things I did back when I turned off the screenshot is I use the unlock key when I entered the password. So there's the transaction, and you can see that that transaction is now pending. And you can also see that this transaction, for some reason, gets included with 940,000 gas, and yes, parity just likes doing it that way. And we can wait. So let us wait a bit.
I have a question.
Yes.
Is there any reason you changed nonce number? Is there
You mean like
any
before
help?
or now?
Yeah, you just make a
So
change.
right now,
What's
because like every time you send a transaction, the nonce goes up by 1. So the reason we have this mechanism is basically so that if I send you 1 ether, then you can't just like take the transaction and like replay it 10 times and give yourself 10 ether. Like every time you do that, you have to send a new transaction with a new nonce to sign it again. Yes.
How do you think about ETC?
Yeah. Okay, so the good news is that this transaction has been included. And I have moved 0.1 ETH from one address to another. Okay, so now what I already did over here is I actually already incorporated like some of the code for creating a crowdfunding contract. And what we can do is we can put in the goal, we can put an iteration in seconds, and we can click create. So once I did that, then the contract code could not be stored. Please check the gas node. So it looks like 1.35 million is a bit too low. Fine, be that way. Parity is unfortunately annoying in that sense. The contract code could not be stored. Please check your gas amounts. What's with these people? There we go, finally success. So now we just have to wait a bit for the transaction hash to actually appear. There we go, success. So it'll think this time it's actually going to log the transaction hash. But what we can do though is we can just look up the address. So what we can do is we can look up the by accounts, and we can look up the account that we sent the transaction from. Maybe you don't need the maybe just use address. There we go. So there we go. see. So, I see. So it looks like we actually have 3 contract creation transactions that are pending. I guess we'll all just have to get included. We can wait. We can wait. Okay, one of them got included. There we go. So it looks like this parity does not yet know about the address. 485, yep. What we can do is we can, I believe, not necessarily, hold on. Actually, yeah, let's just make things a bit cleaner here. So we have a transaction hash. Reading. Not included yet. Basically, we just need to wait a bit more. There we go. So, window of crowd funds doesn't have an address yet. That's just weird. Hold on. Unfortunately, this might be one of those other cases of it being quite silly. Fine, we'll just set the thing manually. Actually, maybe it's because I need to certain metamask off. I don't even know. I don't think so. do though is we can do slightly. We can cheat slightly and say, no, that's not them. Whoops. Oh well. Hold on. What we can do is we can say, window.crowdfund equals crowdfunds.add, and then we can basically just use this address, and we can just point to it directly. There we go. Okay. So basically there's I think this is another one of those instances of something that Parity hasn't quite gotten right yet. But generally, like the way that I would modify the code right now is I would probably just do a loop where I just say, what would I do? Right, so if I wanted to do that automatically, I'd basically probably just save the crowdfund transaction, and then I'd do a loop where I'd check to see if the transaction created a contract, and if it had, I'd grab the address. So, like, there's generally many different ways to do these kinds of things, but the point is that right now, basically, it sees what the address, like, it's detected what the address is, and you notice that it's keeping track of a timer, basically how long the contract has until it expires. So, right now, basically, if we wanted to continue the application from here, what we would do is we would add another set of text boxes that would basically say contribute to the contract. We had another text box that says refund. We would have another one that says finalize. I'm probably not going to go through all of that here because like it's basically the same sort of thing, the same sort of stuff that we've done before. But that's basically what the general principle looks like. So aside from this, I would say some general right. So, like, if you were to make a more complex application than the other, like this interface would probably end up being much more complex, and you'd probably end up being able to see multiple campaigns and so forth at the same time. So, like, actually making the interface for a proper crowdfunding application is something that's not very trivial. I mean, there is actually a service that's actually sort of gone all the way and done this. So it's called Wayfund. It started with like something as simple as this, but they've spent about a year on push moving it forward. So, like if you click on their beta, then you can probably see that it's much more pretty and much more advanced in various ways. See, there we go. So loading campaigns. Yeah. So let's see what else. Now, I will point out that Parity is like not the. I mean, it's not the only Ethereum client. Like, there's probably even more people that are using the Go client. So one of the problems with the Go client is that it does take up more space, which is going to be resolved soon. But like even still, it is a challenge. The other thing that the team behind the Go client is working on is they're actually working on a light client. And so light clients, like when they work well, are really nice because they can consume even less storage. So with Parity, for example, right now it's at 5 gigabytes. And like as I've said, also like the Ethereum's like the state is temporarily bloated because of attacks. So in about a month from now, you can expect this to go down to 1 or 2 gigabytes. But like even still, it is probably fairly compact compared to the Go client, which is right now between like 10 and 30. Like if you look at the Go Lite client, you can see, well, it's 180 megabytes, but like right now, the Litecoin is still in beta, and they haven't even started doing a lot of pruning. So if you do a lot of pruning, you can actually knock it down to basically 30 megabytes. So if you're a more lightweight user, then it will end up being a very attractive choice. Right now, it is, like in some cases, a bit hard to run one of these, basically because the light client, the light client relies on a special light client protocol, and it does rely on full nodes in order to provide the data to the light clients. So, like, the way that these clients work is that they don't store the full blockchain themselves, they only store a tiny piece of information. And so, if they want to download any data, like run any transactions, verify anything, then they have to ask some full nodes for data. Now, this actually doesn't mean it doesn't mean that you have to trust the full nodes, because you can actually verify the data. Like, you can cryptographically verify it against the block headers. But it does mean that you need to have full nodes in the network that support this protocol that the light client can talk to. So far there are very few of these. There are like 10 of them out there, and so there's some fairly hard to connect to. So basically that does mean that the light client is not the most trivial to use. Like, sometimes what would happen is that you would get this missing tree node error, and then you need to wait about 10 minutes, and then it starts downloading blocks again. So actually, I wonder if there are any here. Yeah, so this is still sort of beta public test mode. That said, I mean, there are still things that you can do with it. So this thinks the current block number is about 2.53 million, whereas if you look in reality, it's about 2,000 blocks later. And right now, if you try to do any kind of queries, then chances are you're not going to context deadline exceeded, which basically means it tried to get the information, but it failed to. Other thing that you can do is you can do a let's try this. Let me just see if I can remember what the Keynote URL format. Hex shards, do you? Hold on. $144? That's just weird. Oh, I see. Hold on. Where is it? Yeah, there's the problem. It looks like this, declaration was copied incorrectly. sometimes you just have to like add peers manually, and then sometimes it works. So you can try. Let's see. So aside from the light client, other things that I can show you are, so first of all, let's see. The web compiler is the sort of most basic interface. So like if you want to just start developing your code with it, it's a fairly decent one to use. There are other development environments that we are working on. So there's one that's called Remix that's done inside of JavaScript. And that in there, the plan is to include a lot more advanced features, like being able to debug inside of it, being able to test contracts inside of it, being able to run through contracts code and give much more warnings inside of it and so forth. Let's see if this has done anything for us.
So, do you suggest to run this RPC for the local development environment or the infrastructure service provided by the consensus? Because we don't need to have anything.
Yeah, so if you're running in like in general, running your own node is not very hard. So I'd recommend just running a node and talking to it. In part because, for a few reasons. One of them is just security, and one's privacy. One is if you don't want to not necessarily be reliant on some other node that you don't control be online. So like the client, I would recommend if you have. Chances are you're going to have more space than my laptop does, so I'd recommend running a get node and a parity node at the same time, so that either of them has a problem, you can just switch to the other one. Let's see. It looks like it's listening to some weird local Keynote on here. Right, okay, so hopefully this will, light clients will work better around a month from now. As I said, they're still in sort of public test period, and some of that has been a bit derailed because of, let's see, finally test servers finally back online. The other thing you can try to do is you can try and pull.
Is there any mobile version of?
There are groups that are working on one. So there's one that's called status.im.
Yeah.
There we go. So the status.im team is, as I understand, in the process of building out this wonderful application, including Ethereum things. They've plotted including a chat feature. Basically, turning it into a sort of WeChat-style mobile empire, but more decentralized. And also as I understand, that it's fairly centralized right now, but it's waiting for the light client to become more viable.
No, I'm running Get client right now.
Okay.
Yeah.
Cool. So it's okay.
Yeah, nothing centralized about it.
Okay. Cool. That's actually very good news then.
Yeah.
So they won't have official one. Official.
Yeah. You mean by the Ethereum Foundation?
Yeah.
Not sure yet. I mean, like in general, right? Like it's not necessarily our desire to build like a piece of the like every single piece of the infrastructure ourselves. Like, and we're happy building kind of more low-level components. Let's see if this time it works. still says missing tree node. Oh well. Actually, what if I do? What if I start this from scratch? Let's see how that works. Sometimes starting from scratch actually does get you what you want. I'll just have to wait a bit for it to try and grab some of these servers. And so status.in is one of them. There's also something that's being made from inside of China that's called IM token. But this is, let's see if it's, there we go. But this is like IM token is still under fairly, so it's not as advanced as status is, as I understand. Oh, it's cool. This is actually working now. Block synchronization started. So I'll actually be able to show off the gef slightly.
Do you recommend a new programmer using testnet before they pay too much money on the gas?
Yeah, I mean,
any difference between testnet and
using the test, that's definitely an option. Like Etherscan supports it. So. I mean, for myself, I guess I'm just too lazy to care, because even with all these contracts, I spent like $2 today. Oh, there we go. And it's downloading blocks very quickly. Right, okay, so I think, so what's happening now is that it has to basically sync up to the latest blockchain, because right now the blockchain is at 2.5 million, and it's at 2.36. So we can just wait a bit for this white clients to sync through, and I'll hopefully be able to actually show like how well it works. Any other questions in the meantime?
Do you think a 5 minutes break?
Okay, sure. We can do a 5-minute break.
So we'll do a 5 minutes break. We'll be back here in 5 minutes.
So like using an API for right. Oh yeah, if you want to just thank you.
I have registered still in the waiting list.
What
That's for?
Yeah,
Are you
I would recommend
waiting for release? I'm trying use.
see if this works. Yeah, so unfortunately the light servers, at least that this thing is connecting to, still seem to be down. Like I managed to sync up all the way to 2,000 blocks ago, which is exactly where I was this morning. I stopped at this morning, but since there I haven't gone anywhere. So no luck this time, but hopefully the servers will be better off next time. So another question I got, by the way, is that if you have an application and that application wants to get data from the outside world, then how do you do that? So smart contracts can't access the internet because, like, if they did, then there would be basically a huge number of security bugs that would open up if you try to do that. But there are things that you can do. So, for example, there's a service called oraclize.it, which is basically like a third-party gateway. So the idea is that if you call their contract, you can call their contract with the details of like what API you want to call, and Oraclize will automatically it'll automatically do the API call and then send a transaction back with a response. So, like, this is one tool that you could use. There's also something not quite as generic, but very similar at smartcontract.com. So that's, let's see, actually, smart contract, Ethereum, oracles.
Yeah. Is the screen got shared?
What happened?
It's not switching to whatever you're typing.
That's weird. It's being very slow. Yeah. Hold on. Stop. I'm gonna see if I can. Okay, and I will restart by sharing the screen. Entire screen share. I'm sharing. Sharing is caring. There we go. Okay, so there's a service called Oraclize, so this is one that you can use. There is also one called smartcontract.com, and this is, I mean, it does something fairly similar. Let's see. Smart contract rolls out smart oracles platform. Blockchain.com is offline. Right. Like you can, if you go through their website, you can probably find them. Like they basically do have. There we go. Ethereum smart oracles. All I had to do was just scroll down here. So smart contract create. I'll just use my fake account. There we go. I think that's it. Okay. Sorry, I needed to use my throwaway email. So basically, they have this feature where you can create an oracle, then you can pull data from a URL. So this would be just like a link to some JSON file, and then I don't know, I'll just say http://vitalik.ca/file/blah blah blah.json. Report on the. Let me actually make this path. Add the oracle. There we go. Smart term 1. I'm not sure I care about having this. There we go. Oh, I guess it wants another smart term. Fine. Save. So basically, you can like make oracles over here, and like you can just automatically create oracles that like points to a particular like JSON link, so that they reply back with like basically the results of some JSON path. So like this is fairly similar to what Oracleize is doing in some ways. So there's actually a few of these services. You can sort of look on the internet for them themselves. If you want something that doesn't rely on like a single point of failure, then you can combine several of them and like take the median or whatever. If you're looking for prices, then I'd recommend also like combining several different exchanges, because one of the exchanges could always, look, there's always a risk that an exchange goes down. There's always a risk that an exchange just like shows some crazy price like $1 million. This actually has happened. If you make long-term contracts, there's a chance that like one exchange will just like get hacked and the price on that exchange will go to zero. So basically, like if you are trying to grab data from the real world, then like you do remember that you're not in the realm of these sort of perfectly trustless anymore. Like you are grabbing data from the internet, and you are grabbing it from certain sources, and you do need to trust those sources. So just something to be worried about. Either trust the sources or come up with mechanisms where you mitigate the amount, or decrease the amount of trust that you need to have in those sources. Let's see. Aside from this, the other thing that's sort of worth keeping in mind is that Ether is not the only token on top of Ethereum. So if you want to like, do some development yourself, then the other thing that you can look at is if you look at ethereum.org, then you can go down to over here, and you can do things like you can issue your own token. And here they have Solidity code for basically creating your own token, so kind of like your own cryptocurrency on top of Ethereum. And there have been projects that have done this. So there are, I think, like several dozen assets on Ethereum now. Like there's one token that's backed by gold. There's a couple that aren't yet online yet, but that are trying to make tokens that are backed by dollars. There's some tokens that are like basically like sort of application tokens for their own projects. Look, there's REP, MKR, and so forth. There's some that are there's also like in general there's also some tokens that are trying to target price stability. And if you're trying to do things like an escrow application, then that might actually be important for you. So in general, basically keep in mind that Ether is not the only thing that you have at your disposal, and there are other things that you might need that you might want to consider using. Yeah. And aside from that, in general, like I do recommend that if you're going to be developing Ethereum applications, that you look through all the tutorials here. And I'd also recommend that you try out several different ways of doing things. So, oh cool! Guess what just happened? I connected to a node on the light client. Hey! So, let's see if this works. There we go. So just now you might notice that here, like, there is a bit of a delay when you call get balance. The reason is that like, once again, the light node does not have all of the information immediately available. The way a light node works is that every time you make a call, it grabs the information from like some full node server on the internet, right? And once again, now the light node, once it gets the information, it is verifying it, but it does mean that there is this sort of like round trip that it needs to go through in order to get it. This does have some interesting consequences. So one of I'll go through two. Actually, I'll digress a bit and go into like two other features of Ethereum that I haven't gone through yet, and these are fairly important. So one Ethereum feature that there is this concept of a log. So in general, a log is a basic function called, actually, instead of using, we'll do even more. We'll go through 3 functions. And we'll do event, actually we'll call received. There we go. Now I'll just watch how wonderfully this feels. So one of the reasons why I like the Go client is that it does have this really much more friendly, what context? Deadline exceeded? There's a way around this, and the way around this is generally to here's what the usual approach. There we go, unlocked. Now, unfortunately, because I did restart the node, it might take some time for me to find the server again. But what I'll be able to do is, if you create this contract, then so first of all, this thing has 2 new features in it that I didn't show you before. One of them is the fallback function, and the fallback function basically gets automatically called if you make a transaction to an account that doesn't call any other function. So this is one of the main use cases of this is if you receive money, sometimes you want to be able to log it. Now the question is what are these events? So events are basically something that happens where the events, every single event that gets triggered by contract execution, it doesn't change the state, it doesn't have any direct effect, but it does leave a kind of log that gets hashed into the blockchain. And this log is something that you can, full clients, light clients, everyone can automatically search for. So the idea here, the use case basically is that if you want to be able to search for all instances of some particular event taking place, then every time that event takes place, you want to leave a log, and then you can create an object called a filter and search for the logs. So that's something that should be quite feasible to do. All I really need to do is basically just wait for this node to find a server again. As I was saying, this often does take a very long amount of time. That is unfortunate. So, look, once there are more servers, this is going to work much more reliably. But as you've noticed today, right now it kind of works, but it doesn't work extremely well. So that's the. But like, when it does work, this is like the quality of this thing is actually excellent. Like the light client does pretty much almost exactly the same thing that full clients do. The weakness that it has is that like is basically the latency problem. So if you have some operation that requires doing like lots, basically like accessing the database many times sequentially, then that's something that could take you a few hundred milliseconds on a normal node, but on a light node it'll take you like maybe 30 seconds. And this is something that you want to watch out for when doing development. So when you're doing development, I'd actually recommend that you do use the light client if you can and it works, because basically that way you will know, like you'll understand the struggles of your users that are going to be using light clients, and it'll force you to design applications in a way that is friendly to them. The general piece of advice is to try to just parallelize as much as possible. So like don't do like A, then B, then C. Like if B is not dependent on A, then do A and B in parallel, and then after both of them pass, then do C. So the more you can sort of compress down, I guess, the depth of your circuit, to use computer science terminology, the better. Let's see. Admin peers, this thing's still empty.
I can give you testnet peers.
Nah, that's fine. In any case, this is something that hopefully will get better over time. So this is too bad. Like, I really felt like I got lucky here, and then for some reason the account getting locked has kept on exceeding the context deadline. Right.
To give a basic idea what the algorithm you're looking for nearby peers.
So Ethereum is based on the Keynote network. So the algorithm for, personally I'm not too sure about what the details are. Like I don't really do the networking side, but I think like the challenge here basically is that the number of nodes in the Ethereum network is something like 6,000, but the number of these light client peers is something like 5. So,
5 only?
I'm not sure there actually is a good algorithm, because like it's not basically Ethereum is like it's not really the underlying dev P2P protocol isn't really designed for the case where only like 0.1% of a certain kinds of node does speak a particular protocol. It's more intended for the case where it's like lots of nodes use every kind of protocol. Let's see, unfortunately it's still not. Perhaps at some point I might just start running my own server, but that'll take more gigabytes than I have. Yeah.
Is that the reason you want to avoid some miner together, with a nearby peer? So you try to looking for a far away peer. That's the reason we really have to synchronize the blockchain.
I don't think it has anything to do with miners. Like the thing, basically, like the problem here is just the fact that there aren't, like the light client protocol is still very early and technically not yet released, and there aren't many peers that know about it. Like if you noticed when Parity was running a full node, it was running very well. So it's not quite the same kind of problem. Let me just check one last thing. Maybe that one here will be able to do something. Right, looks like it did manage to connect to that one here, but I'm not sure exactly how much that's gotten us. Not much. Yeah. general, I guess if anyone has any final questions, I'd be happy to answer them. Yes.
It's a very serious question because most of people they write smart contract they believe is not changeable, right?
Right.
But some way you write program you can actually change the code. Is that true in Solidity?
Kind of.
Yeah, kind of design pattern you can.
Yeah, there's design patterns that you can use where if you want your contracts to be upgradable under certain circumstances, you can do it.
So, in that case, that we cannot trust any smart contract.
No, because like not all contracts have that design pattern in them.
But if someone they design in that way, but most of the user they don't know.
Right.
They just assume the smart contract never change.
Well, hold on. So like if part of your model is that users don't look at what the code is, then that would mean that like in that model the contracts can do whatever they want and you can't really trust any contract regardless, right? So like part of being able to trust a contract is actually being able to see that what the contract's code is and seeing the contract's code does what you think it does. And if the contract is modifiable, then what that means that like that fact will be part of the contract's code, right? It will be part of the code that it'll be designed in a way where that can be modified. So it's not something that you can sneak into a contract easily. It looks very different.
So you mean when we want to run the smart contract, basically we have to see the source code, right? Is that correct?
Well, if you want to like personally prove to yourself that a contract is it does what you think it does, then yes, you'll have to like look at it yourself or trust someone who did.
So you suggest that every serious smart contract authors publish and verify their smart contract source code on the surface of the scan, so others can see can check their source code and so.
Yeah, like in general, I mean, like as a regular user, you might want to even do a combination of things where one of them is looking at the source code yourself, one of them is just Googling the address and see if like people have said any kind of warnings about it. Oh, by the way, I just connected to the server again. So you might notice that I did send a transaction. So over here I send this transaction, and you can probably use Etherscan to look at it. There it is, it's pending. Now you might notice that unlike parity, the Go client does not force you to include a huge amount of gas with every transaction. Imported a header. Now, okay, this will still take a while. So right, so look, what you see here, like the interface of the light client here is basically exactly the same as the interface of the Go full client. You might notice that when I sent a transaction, I was able to like do that fairly quickly. Now I basically just have to wait. Still pending, still pending.
So is the maintainer of Etherscan from the foundation?
No, it's an independent community project. There we go, yay. Okay, so I just included it. Now what we're going to do is what we're going to use is the interface. eth contract dot add, and we're going to use the ethers. No. This address. Hold on. There we go. And now what we're going to do is we are going to we're just going to send a few transactions to it for fun. There. And we'll wait for these transactions to get included. So now what we can do, yeah, so let's just, okay, so you can see there's like 4 of these transactions and they're basically all pending right now. Importing all headers. Now what we can do is we can set, what eventually we're going to be able to do is we're going to be able to say, if you call C, now you might notice that C has a log and nothing's happened yet. And ooh, all 4 of these transactions failed. I wonder why. Bad jump destination. So in general, when you see like an error like this, then basically that means that some error occurred and something went wrong, and you might want to just look to see what happened. Hold on. Then okay, the call value opcode hit. Then the push 1, jump by. So somehow something weird happened here.
We need to say
Hold on. Right, so if you look at the VM trace, like basically what it's done so far is push 1 value mstore, called data size if it's 0, then it called the fallback. And then over here it used the call value opcode, which is the same. Basically, that corresponds to msg.value, then it should be calling calling received, and this should just be logging it. But this is not what's happening in this case. Yeah.
No, the function needs to say it is payable, so that you can send the either to.
Oh right. Hold on. That's probably true. Yes. Yes. Okay, so we can try this again. Let's try that. And we can wait a bit. The other weakness of the like line is that like get transaction does not work on it yet. I mean, theoretically, I think it is possible to make it so that you can do it in the future, but it relies on some more sort of complex mechanisms. one of the, this does lead to problems in some cases, but this should be fine. I'm just making sure that I'm doing this correctly. Yep, the gas price is 50 billion. Still 40611. And sometimes it does. I think one of the challenges here is that I'm sending the transaction through a single node. So we can see it's at the point, like it's still at the point where it's unable to locate the transaction entry. Maybe the server has not propagated it. I don't know. The last transaction had a nonce of 603, which makes the current one 604, which is exactly what you'd expect. We'll try rebroadcasting it with a higher gas price. We'll see if it passes through the second time. There we go. It passed through this time. So now we just have to wait a bit, and this should get in very quickly because the gas price is about 4 times more than what it needs to be. There we go. See, one block immediately got in the next block. So created. Now what we can do is, we created this contract, and we can try to do that. And hopefully, so now what we're doing is we're just basically sending a tiny amount of ether into this. Pending. I'm gonna bet it'll make it into the next one, but we'll see. Okay, next one came. Not unable to locate. There we go, it's in. So now, one thing that you can see here is if you look on Etherscan, there's a new tab here called Event Logs. So we created a new log. So now, how do we look for these? Let me just send a couple more of these just for fun. 01, 02, and 02. So what we're going to do is we can create book3.eth.filter, and we can say, or actually the alternative is we can do eth.contract. This is probably the more correct way to do it. We'll put in the interface, actually C equals the effect contract dot add. And now we're going to put in this address and C dot received. If you do a dot get, so if you know, so here what I did is, if you notice, so C is the contract JavaScript object, and you notice that it doesn't just have methods for the functions; it also has a method for every events type. Now, if you look at the events type, so if I did C dot received, then it has this function. What you do here is you call it once with the from block. You have to specify what block you want to scan from, and you can do dot get. So this, actually, hold on. What did I do over here? I think what happened just there is basically that like it's not returning any new ones. So if I now send another transaction, let's say, I don't know, 0.203. Once this gets confirmed, basically, I think I should be able to get another one. There we go, new transaction, it's pending. And it obviously went in extremely quickly. So there's another approach to filtering, which is you do that. So the approach here is basically that instead of using the contract objects, you can just make a direct filter, and you can make a direct filter that just fetches all the logs associated with one particular address. Specify a from block, and you just do a get, and that returns all of them. The other thing that you could do is you could also do do something called watch, and then you can do and then like basically you have a watch and the callback gets called every time you see a new one. So like that's also a possibility. So yeah, I mean I'd say those are probably the main features that I'd recommend watching out for. Otherwise, I mean I think we've covered all of the basics. If you want more kind of advanced information, then I'd also highly recommend looking at our wiki. So the web pages that are fairly important include a JavaScript API, probably a JavaScript API. I would also recommend Solidity. There we go. So basically the wiki is like here, github.com Ethereum wiki. Highly recommend going here. JavaScript API is the page that contains like all of the JavaScript stuff I talked about today. If you want to talk to a notable JSON RPC, there's that as well. If you want more like learn about Solidity and all the features of Solidity, then you can go over here. So hopefully people will be interested in start writing their own cool dApps.
Do you have a tutorial page?
Huh?
You got a tutorial page?
Yes, and right, the tutorial page. That would be ethereum.org. Basically, if you go to ethereum.org, then down, like issue your token, there's a tutorial. Kickstart your project, there's a tutorial. Create a DAO, there's a tutorial. So basically, just go to our website, and there's a bunch of them. And we try to be very nice and friendly and give sort of a good walkthrough. The walkthroughs here actually, like what's in there, they rely on like they all use Mist, and Mist or the Ethereum wallet, which is like our own user interface. The tutorials I went through today, you might notice that they use like a combination of the command line and the Solidity bug compiler. Like you can use either one. there are lots of different ways to do things with Ethereum. It's an open platform. There's no one way to do anything. So feel free to explore all of them. And I'd actually recommend trying out different approaches, because the more you try out different approaches, the more you understand how things sort of work on the bottom. Yes?
I think we have one question from our live stream audience. The question is, what are the major milestones in the development of Solidity language?
The development of the Solidity language?
Milestones.
Yes. So I think right now there's probably two major directions. One of them is generally adding new features, and we're interested in adding support for various kinds of asynchronous calls, callbacks, events, more advanced data structures. And the second major direction is security. So with security, there's a few different areas. One of them is that there's a movement to try to, harden Solidity and to try to make the language more intuitive, so make it go more in the direction of doing things that you expect it to do. And one very simple example of this is actually that basically throwing every time there's a math overflow. So this is something we want to do currently wants to do in a future version of Solidity. And that way, programmers don't get surprised by weird overflow bugs that say that 1 divided by 3 is some really crazy number. Figure out what that number is. I think that's how we do it. Sorry. Yep, it's this number. This is 1 divided by 3. No, so actually, you don't want, and you also don't want 1 minus 2 to equal this. So basically, the idea is to try to make math sort of more intuitive in the way that humans think math should work, rather than the way that crazy computers think math should work. Then there's formal verification. So I think one of the more recent things that we've looked at is, there we go, this. So basically try to, the idea is that we've integrated Solidity with a Y3, which is an automated theorem prover, and then you can use this funny language to state claims about what your code does, and the checker will automatically try to prove those claims. So the idea here is this is a line of defense against your code having bugs in it. So you can try to state invariants claims about what properties your code has. And if you accidentally make a mistake so it doesn't have those claims, or so that it doesn't satisfy those claims, then it'll automatically flash a warning for you. So that's one sort of major set. Yes.
That's some kind of unit testing or dark testing.
I mean, we do need. Testing is definitely part of it, but testing is more of a role for the development environment. So, inside of Remix, our IDE, there are, as I understand, there are plans to add various kinds of testing features.
You mentioned that zero-proof knowledges will be implemented in Ethereum maybe late next year.
Yeah.
What's your thoughts on that? How's that going to look?
So in general, the simple building block is basically just either a precompile or an opcode or something similar to do the verification for a zero-knowledge proof. And that's the basic building block. You can build stuff on top of it. One of the sort of nice higher-level abstractions that I like is there's something called Hawk. So if this is, so far it's mainly a white paper. It was done by Andrew Miller and a few people out of Cornell. But the basic idea is that you have encrypted contracts and encrypted transactions. And for every contract, there might be a couple of people who have a decryption key. And only if, basically, the idea is that someone with a decryption key can create a zero-knowledge proof that states, here's like here is what the old encrypted state was, here is an encrypted transaction, here is what the new encrypted state is, and here is a proof saying that the whole transaction is valid. And that way you have the blockchain verifying the contract's validity, but you're using plain old encryption to make sure that the data is private from everyone except for the people the contract is between. Yes. So this is not quite as good as obfuscation, because with obfuscation you don't need anyone to have the decryption key, but this is still quite impressive, I think. So like the goal is to move towards something like this. Yep, thanks. Yes.
Most of people want to use other language to
Right.
go with Solidity. Is there any way, for example, Python or?
Okay, so Python is not likely because it's too slow, but like for things like C++ and Go and so forth, there actually is a path. So we are planning on making some improvements to the EVM over the course of the next year. Basically like adding a bunch of features, like potentially adding some 64-bit features to it. And the idea is that look, there is a path that you can take to make it basically make the EVM a compile target for like common tools like LLVM and so forth. And this would let you write smart contracts in like whatever language you want with the right tooling, and that way, and then you'd be able to push it onto the EVM. Okay. Yes.
I've read your article on the transaction fee and the inflation and
yes.
how it influence the security of the network.
Yep.
And how I use raw estimation on all figures. How do you think you can improve the improve that research?
So I think part of it, like part of improving security is a few things. Like one of them is just switching the proof of stake, because that'll get you like similar levels of security more cheaply. Another one, and there's a few smaller protocol tweaks that you can make to try to make the algorithm work better with like even if attackers control very large portions of like the hash power or the stake. There's another set in things that you can do is there are protocol changes that you can make to try to like make the protocol more game theoretically robust. So like deal with like there's one of the problems I mentioned in the article, and like actually there's a few academics that like raised the exact same concerns in a paper about a week ago. Like if transaction fees are too dependent, or if minor rewards are too dependent on transaction fees, there are these weird game theoretic issues that you have to deal with. And there are changes that you can make to the protocol to try to solve some of those problems. So I actually talk about some of them in the blog post. I mean, like that sort of, like we are planning on thinking about that sort of stuff and potentially including it in like the next 2 or 3 hard forks, like at the same time as we switch over to proof of stake. I think like in general, security against 51% attacks is something that like there's only so far that you can optimize it, because ultimately if someone does control most of the stake, then they can basically they can't, it's not quite wreck the system, but they can basically do a lot of nasty things until you basically issue a patch to sort of kick them out of the system. I mean, that is one thing, the one option that you do have in proof of stake that you don't have in proof of work. But like basically, there's necessarily going to be some economic limit to the security of a system. And at some point, you can make optimizations, but beyond the optimizations, there's not that much more that you can do.
Is a recursive coding technique still an issue?
Yes. I mean, theoretically, de-entropy is something that you do need to be worried about. I mean, there are some programming techniques that you can use to avoid it. So one of them is that you can avoid like making state changes after you do a function call. One of them is that you can avoid like if you just need to send someone Ether, then you can just send them with a minimal amount of gas, because if you send the minimum amount of gas, then you don't have enough gas to do the reentrancy attack. I would say those two are the main ones, and then you can also, like, in a few months, you'll be able to try and use some of these formal provers to automatically show that there aren't any reentrancy issues. So, like, it definitely is something that you as a programmer should watch out for. Although I will say that, like, in general, like, all of the applications that I made today, they don't have any reentrancy issues. So it's only something that appears once you start making things that are a bit more complex. By the way, if you want to kind of learn more about security issues, then there is, once again, on the wiki, there is this really nice article, safety. There we go. And you can just, like, scroll through this. So, and I also recommend looking at it.
Is that Solidity try to add other cryptography, like analyze something like have some feature like homomorphism into the Solidity?
Add some kind of features like what?
New cryptography.
So the problem with new cryptography is basically that in order for it to be added into Solidity, it has to be done inside of Ethereum in some way. And right now, the EVM is unfortunately a bit too slow to do it well. So like, it'll be a combination. There's two strategies. One of them is that we just explicitly add opcodes for like some cryptographic operations. And one of them is that we just make the EVM faster. And like, we are pursuing both approaches.
Okay, do we have any more questions from the audience? Any more on the live stream? No?
So
okay.
So Hawk is the privacy preserving. So if we want to turn Ethereum into one.
Turn Ethereum into what?
Into one that's privacy preserving, then we have to rebuild a whole system. Like using the injected proof system, like the Zcash.
I'm not sure what the question is.
Okay, now the transaction's in the clear, right?
Yes.
Okay, so you want to turn it into something that the transactions, we do not know who received what. Who received from whom? Then how hard is it? Is it going to turn?
I mean, turning like the entire Ethereum system into something like that is very hard because okay. Like even Hawk doesn't let you do that because like with Hawk someone has to have the decryption keys. Right? And like with individual contracts, that's fine because like you can just say that the participant stage contract have the decryption keys. But like you can't really do that with the entire system. So if you want to like make all of Ethereum dark, then you have to look at things like homomorphic encryption, and those are still like much earlier stage and much more inefficient.
So private, so you can make one or two contract to be.
I mean, with Hawk you'll be able to, yes.
Okay.
I think the goal is that, like, once you have enough of these privacy-preserving systems, and once we figure out how to make them talk to each other, then like Ethereum as a whole will be easy to use in a way that's private enough. Yes.
I've heard that the next version is going to be proof of stake and proof of work hybrid. Is that correct?
Maybe. I mean, a lot of the details are still undecided.
There are many kind of language to implement Ethereum.
Yes.
Why do that? Which one is active? Which one is, for example?
I mean, there's a few reasons to do it. I'd say. I mean, one of them is that it helps make the ecosystem more decentralized and remove the dependence on a single development team. One of them is that it makes it more robust. So like for example, back when we had the DOS attacks about a month ago, some of them did manage to like make one of the clients very slow or like knock it down completely. But in pretty much every case where like the other client always did relatively well. So the like basically because we had multiple clients, there was no single instance where the network just stopped completely. So I mean,
which one is active? I mean, why some Java or Python, there are not so many people working on that?
I mean, for Java there are people working on it. For Python, I mean, I think it ends up just Python is unfortunately too slow to run a full blockchain node off of. I mean, some of these implementations do, like, their teams are like fairly small. The ones that are most well developed right now, I'd say, are probably the Go, followed then in Parity, and then followed by Ethereum J. So, like, if you see on each stats here, like, you have people running nodes that are from all three of those.
I have a source code question because I study a little about that. It seems that button lines, they are all called the same JavaScript. So every language, they have simulation to run the JavaScript. Is that true?
What do you mean?
I mean, in the source code, they really call Web3, right? No matter what language it is underlined, they're using the same engine.
If you have an application, then, I mean, so first of all, there are different ways to write an application, right? Like, using the Web3 JavaScript API is one way to do it. But if you want, you can also write an application in native code. You can use IPC to talk to a node. And there are a few applications that are written that way. I mean, JavaScript is mainly the one that we kind of promote the most because it's the most convenient for developers.
Yeah, I know. I mean, for the different language implementation,
I see.
Ethereum, and the bottom line, they always call, they have to run this JavaScript engine, right?
No, so there's different sort of layers of the stack, right? An Ethereum node by itself doesn't need any JavaScript. If you want to run an application, like Geth and Parity and CPP Ethereum, they all do so have a JavaScript engine inside of them, so that you can like call the like use a JavaScript console and so forth. Sorry, Geth has a JavaScript engine inside of it. I think Parity doesn't quite go that far. I think that it just has the JSON API. Like, if you want to interact with JavaScript apps, all you need is the JSON. It is support for the JSON API. Yeah, so like it does. Like in the case in Python, for example, like the Python client, you can use it. You can theoretically use it with applications, but it doesn't have a JavaScript engine. But it does also. But it also like does have a JSON parser. It supports the JSON API.
Do we have any more questions? No? Let's give a round of applause for
Coming back next year?
Next month. Welcome. Always.